A particle moves in a straight line and has acceleration given by a of t equals 12t minus 2. Its initial velocity is v of 0 equals 3 centimeters per second, and its initial position is s of 0 equals 6 centimeters. Find its position function, s of t. So if we want to start with acceleration and find position, we're going to have to antidifferentiate twice. If we antidifferentiate once, that will give us velocity. The antiderivative of 12t, well, the antiderivative of t is t squared over 2. And if we take that 12 and divide it by 2, that'll give us 6. So 6t squared minus 2t, and then plus a constant. Now, we know something about the velocity. We know that the initial velocity is equal to 3. So if we plug in 0 for our time, that's going to give us 0 minus 0 plus c. And so that was equal to 3, we said. And so that tells us that c is 3. So the velocity function is actually going to be 6t squared minus 2t plus 3. You can't always assume that the initial velocity is the value of that constant. It was here because all the other terms vanished, but if our acceleration function has a trigonometric function, for example, sine or cosine, or an exponential function, e to the x, those are not necessarily 0 when the input value is 0. And so you have to be careful. We actually have to go through this step of plugging in 0 and seeing what we get, because there are examples where these other terms don't vanish. So just be careful. There's a reason I'm doing this. There's not this beautiful shortcut that we can take and I'm just making life harder. We have to do this because sometimes those terms aren't going to cancel. All right, I'll get off my pedestal and we'll continue. We've got the velocity. To get the position function, we need to antidifferentiate again. If we antidifferentiate 6t squared, the antiderivative of t squared is t cubed over 3. If we take that 6 over 3, that gives us a 2. So we've got 2t cubed minus the antiderivative of 2t is t squared. Then we've got plus 3t and plus that constant d. We already used c as a constant, so now we've got d. And to figure out that constant, we know the initial position is 6 centimeters. So s of 0, which is 0 plus 0 plus 0 plus d equals 6. That tells us that the value of d here does happen to equal 6. So we can plug that in and get our final position function, 2t cubed minus t squared plus 3t plus 6. And this is measured in centimeters because, well, the problem is in centimeters and speed would be centimeters per second, and then position would be centimeters. So there we go. We have the position function.